So, welcome everyone to Guided Study Group week 15 of Math 140. So, this week is going to be the last week of materials for Math 140, and then next week we're going to kind of have like the final exam review sessions so that to kind of like end this course nicely and give you guys like a good preparations, kind of like finalize everything together, and hopefully it's going to help you prepare for the exam. So let's get started today. So today we're gonna be working on the last piece of materials. As I said, is section 5.2 and 5.3. So basically two procedures or like two methods to find the volume of solid using integral, and these solid are usually solid of revolutions. So let's 5.2 is the method when you say if you have S be a solid that lies between x equal a and x equal b. So say in this graph, this is a and this is b. If the cross-sectional area of S in the plane px, so this is the cross-sectional area through x and perpendicular to x-axis, so this is perpendicular to x-axis, then you have the volume is gonna equal. Basically, what you did is when you rotate this piece around the x-axis. So this is the volume that you're gonna have. So the first method in 5.2 is basically you divided this piece of solid into several disks, which each of them have area axi star and thickness delta x. So when you slice them into many disks and you sum the volume of every disk together, that's when you're gonna have the volume. So this is gonna equal kind of when you slice them very small and very like thin, and then you sum them all together. This is what you do when you find integral. So it's gonna be the integral from a to b of that area ax dx. Solid of revolutions. So yeah, that's how we call the solid that when you rotate, say like a piece of area around an axis. So that's what you're gonna have end up being like a solid. So that's all. That is what we have. So to use this technique, there are a few things that you have to do. So say if you want to find the piece of solid, of course there's one thing you have to find is the boundary a and b, and this thing can be done, say if you are given two curves, and that's usually this case, say like two curves like this f and g, then you define a and b by find the intersection of f and g, and maybe sometimes even more, like maybe you have f and g and then another intersections come from f and the rotation of axis, you never know, the axis of rotation, sorry. Then you have maybe a vertical solid, so say things like this, but you rotate it around this way, so what you end up having is that you're gonna have like something like this, right? So this is a solid, so when you have that, so you basically apply the same thing. So when you slice them into small pieces like this, so when you slice them into more small pieces, what is still like the area of what is the cross-sectional area? And so the cross-sectional area this time, this is going to be vertical solid is going to be a of I, because now everything is in the I axis and you rotate it around. So this one is going to be cross-sectional area is Give me a second and see. So that one is gonna have thickness is dy, and the solid is going to be, so this is the piece of that, and then you turn it around, it's going to be kind of, this is the, so it's going to be pi, outside is going to be fy squared minus gy squared, with f is the outer function, fy, and the inside is gy. So when you take the square, basically, because it's the circle thing, so you just subtract it, like subtract the inner circle and the outer circle, the outer radius is f. So, and then you just use all of these, plug all of these components into the formula that you have earlier. Another thing is you have washer. So washer is when you have a holes inside, something like this or this one. So washer is when you have a line inside, and then this is the hole that we have. So to do that is, again, similar thing. You have thickness, now it's dx. Remember, this is thickness. If you draw it out, it will be very easy to see. So thickness is dx, and the area is going to be, again, outer radius minus inner radius, and then each of them is a circle, so you're gonna have pi. So I would say outer radius is f of x, inner radius is g of x. So this is, we have f squared x minus g squared x. So that's the washer, that's the component that you're going to be using. Axis of revolution, not x and y axis. So in this case, what you have to be careful, again, the thickness is going to, again, based on whatever, what is the thickness and what axis does it rotate by. But the radius, this term is not just going to be as similar, as easy as fx and gx. Basically, say if you have is rotate around this curve and this here. So I wouldn't say fx minus gx, I'm just trying to do it simple. But in this case, if it rotates around this x equal, no, y equal -1 axis, so the radius this time, it is going to equal, so radius is going to equal, this is fx, so you're going to have fx plus 1, because this is, when you have fx, that is the distance to the x-axis, but your radius is 1 unit more than that, so you have to do plus 1. Therefore, your area this time is going to be pi, cross-sectional area at every single point is going to be x plus 1 square. So that is your cross-sectional area. We're going to see that in the next example, but basically these are all of the cases that you might or you should expect in maybe even the exam or the homework. Now, let's see in the first example. It's question 12 of section 5.2. So the way we have is find the volume of the solid obtained by rotating the region bounded by y equal x cubed, y equal 1, and x equal 2. So this is y equal x cubed is here. Y equal 1 is here. And what x equal, x equal 2 is here. So basically it's this region, and you rotate it about the line y equal -3. So rotate this thing around this one. So whatever we're gonna have is going to be this solid over here. So sketch the region. We did the solid and the typical dishwasher. Now we have to find the volume. So first of all, we have to identify this is a washer because we have a hole inside. And this is rotating around an axis that is not x and y axis. It's around like y equal -3. So as I just said in the previous slide, we have to find what is the right outer radius and the inner radius. So outer radius is going to be x third plus 3, because x third is just the distance until the x-axis. You still have 3 more units to go. And the same thing for the inner. It's going to be, this line is y equal 1, so the inner radius is going to be 4. So this is outer radius, and this is inner radius. So our volume is going to be, and we can clearly see that. So first we have to find what is A and what is B as well. So just by on the graph, it gave me A is equal to 1, B equal to 2. Therefore, you have the volume is going to equal from 1 to 2. And the cross-sectional area is the outer radius minus the inner radius, because so cross-sectional area here is going to be kind of like pi r1 square, which is outer radius, minus pi r2 square, because both of them is a circle. You have a bigger circle outside and a smaller circle inside. So the cross-sectional area is going to be the bigger circle minus the inner circle. If you look it on, just like looking at it this way, this is what is going to give you the cross-sectional area. This is R1, this is R2. So kind of that is how we're going to come up with. So to find this area, it's going to be pi r1 square minus pi r2 square. And it's not necessarily all the time that the cross-sectional area is a circle. It's just this way is just kind of like a general idea. Sometimes the cross-sectional area can be a rectangle. Then you're going to have a different way to find what is the cross-sectional area. So in this case, you have pi. So inner radius is x squared plus x cubed plus 3 square. That's outer radius, minus inner radius is 4 square dx. And so we're gonna solve this. Let's see what it gave us. Is x6 plus 6x cubed plus 9 minus 16 dx. So it's gonna give us x6 plus 6x cubed minus 7 dx. And this should be easy to find. Integral 1 to 2. And if you do the calculations, what you end up having is that it's going to be 471 pi over 14. So that's my final answer. So the calculations is not that important. It's more about like setting up the problem in this situation. So you must be able to see like, okay, what is the axis? What is the cross-sectional area? If you necessary, just draw this one out and see what is the outer radius or the inner radius, and that is also depending on what is your axis of rotation. So that is the first example. The second example is question 16 of the same sections. So find the volume of the solid obtained by rotating a region bounded by y equal x squared. This line, and x equal y squared, about x equal -1. So if you grab it out, you can see the fact that, okay, the axis of rotation is this thing. So it's not just 0. So the radius, say if you rotate it, again, the cross-sectional area is a washer. And you have inner and outer radius as well. So again, we're gonna try to find what is the volume. So first one, try to find what is the inner and outer radius. So the inner radius is, so from this line, to here. So, and then you rotate it, so thickness is dy. Thickness is dy. So radius inside is going to be the distance from this line to this line. And everything we do now is going to be on y-axis. So this one is going to be in the radius is going to be y squared plus 1. So this is y squared, and this distance to y-axis, but you add 1 in it. Now the outer radius is going to be whatever y is here plus 1. So it's going to be, so we're going to rewrite this function as x equals square root of y. And then, because we only talk about the positive here, so it's x equals square root of y. And from that distance, so the distance here is going to be square root of y plus 1. So square root of y is the distance from this line to y-axis, and then add 1. So then we have the volume is going to equal. Oh yeah, you also have to find what is the boundary. So the boundary is what is A and what is B. Now, because everything changed into y-axis, so you have to be able to find what is this point, and what is this? So the 2 point of two point of intersection is first is 0, and the second one you have 5. So basically, what you're gonna do is you're gonna set y squared equals square root of y, and you solve for what is y in this situation. Okay, y. So you have y is not 0 because 1 is one of the solution over there, so this one is not. So you have y square root of y is equal to 1. Basically, you have y equal to 1. So b is 1. And so it's going to go from 0 to 1 of a cross-sectional area is going to be pi r squared minus pi r squared. So it's going to be square root of y plus 1 squared minus y squared plus 1 squared dy. Now things should be easy to find in this situation. So I'm just going to expand the square and then try to solve it. Try to find what is the integral. So your v right now is from 0 to 1 pi. See what we have here. So we have y plus 2 square root of y minus y fourth minus 2y squared dy. And this one is very easy to find right now. So you have 2 y squared over 2 plus so you have 6. So let's see, you have 2 multiplied 1 over 3 over 2, y to the 3 third minus y fifth over 5 minus 2 over 3 y third. And then that one's from 0 to 1. This is what we have. Plus 4 over 3y this minus. So what we end up having is if you try to do the calculations, this one is going to equal 29 pi over 30. And this is all because calculations is very easy. Just figure out what is the inner outer radius, and this is a little bit challenging in the sense that okay, you have to see the fact that okay, because it's rotated around this line, so everything is gonna put into y, because here you just very easy, you look at the thickness of the disk, it gives you okay, it's dy, so you know the fact that you have to put everything into y. The same thing if you find thickness is dx, you know the fact that you have to put everything into x. so that you can solve the problem. It even got a little bit challenging here because the axis of rotation is not just x and y axis, so that's another one extra step to do. And then you also have to find what is the intersection point with a and b, like the boundary for you to find the integration. And remember, that has to be in y. So when you solve this, it's going to be in y, so y equal 1. And you take it, if you solve for x, then after x, you have to put everything into y again to take that value of boundary. Now that's example 2. And also all I have for 5.2. Now we're going to go to 5.3, cylindrical shells. So this is just another method to find what is the volume, but instead of sliding it to many thin slices, in this case you put it into many shells and you solve for what it is. And you sum them all together. So method of cylindrical shells: cut parallel to the revolution axis to get thin cylindrical shells. Each shells have the volume of V equal 2 pi RH delta R. And here, if you look at this picture, the delta R here, so delta R here is going to be dx, see here, dx on the x-axis. The h value, the height, is going to be whatever fx here minus 0, because it's just fx rotated around that. So the height here for each of them is, you see here, is just fx. And then r is going to be the radius from this very inner point into whatever inside, which is going to be x. So that is the same step. Basically, different things that you have to worry about is what's the height, what is the radius, and so on. So the volume of the solid obtained by rotating that around the y-axis of the region under this curve from x equal a to x equal b. Also, you have to find what is a and what is b. So you also need a and b. So that one is volume is going to equal the integral from a to b, 2 pi x, because x here is the radius, fx is the height, and dx. And so just basically the same thing we're going to apply for the whatever shape that we're going to be given. So note to notice here is that usually this is where you're going to see what method you're going to use. So if you have y equal fx and it's rotate about x-axis, so this way, you're going to use dish and washer. If you have y equal fx rotating about y-axis, you're going to put it in cylindrical shells. But that's not the general case. That's just something that I noticed during my time as like a student and also a tutor. But I would say in many ways, both of them should work. It's just which way is going to be easier for you and simpler calculations. Yeah, and so let's see what example do we have here. So example 3 is question 18 of section 5.3. Use a method of cylindrical shells. So it's specified for you, you're going to use method of cylindrical shells. But I would say in homework and exam, that might not be the case. But at the same time, in homework and exam, you're going to get more time and also more experience dealing with these already. So that shouldn't be a problem. So to find a volume generated by rotating this region by x equal 5. So x equal 5 is here, and you rotate it around. In this case, the thickness is again dx. So let's identify everything we need. Thickness, dx, radius, height, and so boundary A and B. So the radius here is going to be whatever distance from one point here to this axis, which is going to give us, so this thing here is x, this thing here is 5, and so the distance over there is going to be 5 over 5 minus x. Now the height is going to be the upper curve minus the lower curve, so it's going to be square root of x minus square root minus half x from A to B. So this is A and this is B. So if you solve for their intersection, you're gonna have square root of x equal 1/2 x. So solving for that is going to give you x equal 2 square root of x, or x squared equal 4x. You have x equals 0 or x equal 4. So for that is A is 0 and B is 4. So our volume now is going to be from 0 to 4. 2 pi r is 2 pi 5 minus x. Height is square root of x minus half x dx. And now let's solve it. So I would say to stress here, the important part is how to be able to set this thing up, not to do the calculations. So I'm just gonna go through the calculations very quickly in these questions. So of course, when you have time, you can check my work at home, but the calculations is not the main thing in this material. So you have v equal 2 pi from 0 to 4. Oh, wait, hang on. It's from 0 to 4. Yeah, so we have, what is the thing inside? It's going to be, oh, now we're just going to take the integral in. Just 10 over 3 x 3/3. 2 over 5. 0 to 4. And I mean, I think I plugged in the wrong number for my solutions, but in this case, I can just quickly go through it. 2 pi, that's gonna be 2/3. 4 square. 2/5. 2/3. So this one is 2 pi. 20. 64. A over 6 is 4. So you can continue to do the calculations, but the most important part I would say here is let's try to do all of this. Write all of them out, and everything that you need to do inside is so much easier. So again, you look at here, the thickness is dx, so put everything in the form of x. So now we're gonna go to the last example of today. It's question 42 of section 5.3. Find the volume of a solid obtained by rotating this region bounded by that about y equal 1. So in this case, I'm gonna try to do it by both method, cylindrical shells and washers, for you guys to like kind of see that both of them should work. It's just which one is easier for you. So this is gonna rotate about y equal 1. So let's do in cylindrical shells. So let's do that one first, and we're gonna do the other one. So again, what is the thickness here? So see, like when you rotate this one around, what you're gonna be having is so it's gonna be like a solid like that with the hole in the middle. So this is gonna be a hole. So not just. So let's say cylindrical shell. So thickness. So each of them. So when you slice them into thinner and thinner, the thickness here is gonna be dy. So you're gonna put everything into y this time. Radius, height, and AB. So everything has to be in the form of y. So let's see. Your first y is going from 1 to whatever the intersection here. So you're gonna have so it's going to start from 1 to whatever over there. So it's gonna be y equal 3 square equal to y equal 4, x equal 4. So set this one and this one equal to one another. Solving for that, what you end up having is that it's going to be y equal 5 and y equal 1. So you're going to have second boundary is 5. Now the radius is going to be any point from here to this line. So see, any point from here to the x-axis is x, is y, and you just subtract 1 from it to be the radius. Here is going to be y minus 1. So the radius is y minus 1. And then the height is going to be, then now you look at the height is from here. So you can see the fact that the height is going to be upper curve minus lower curve. So therefore minus y over y minus 3 square. So now using cylindrical shell, your volume is going to be from 1 to 5. 2 pi r is y minus 1. And the radius 4 minus, the height is 4 minus 1 minus 3 square dy. And so you can continue to find what is the volume in this case. I got is 128 pi over 3. But I'm not sure about the calculations. You guys can work on it. Now, if we use washer, so washer is where you slice it into smaller and smaller pieces. So again, let's see what is the thickness here. Thickness, when you slice them into smaller and smaller pieces, it's going to be thickness dx. So put everything in the form of x. And let's see what you need outer radius. Because here you have the cross-sectional area be a washer again. So you need outer radius and inner radius. And also what is A and B. So the outer radius is going to be this curve. And so that one is going to be, you have to write everything in the form of x. So hang on. Let's see if we have, oh, actually thickness here is dy, not dx. I don't know what's wrong with this computer. Give me a second. So let's see when we come back to this. Okay, so the thickness is not dx, but it's dy. Why? Because and so what happened is that, let's go to the next one so it's easier to work this thing out. So you have a curve like this, x equal 4, y equal 1, and this is the curve. And this is x equal y minus 3 squared. So when you do washer, you slice it into small pieces, small slices. So what we end up having is that we're gonna have something like this, and then the thickness of that slice kind of confuse myself right now. Give me a second. So let's see, this is the, so in this scenario, each of the slices, and you rotate it around this, not the x-axis, but this axis. So there should be not really a hole inside, but think this graph is also wrong because so in this scenario, when you rotate it around the axis, so this axis, so what we end up having is it's not the exact hole because there will be some of the point that you will eventually eliminate the hole. So like here, you're gonna have no holes at all. So when you rotate it around, let's see what is the radius. So what we need to find is washer. You use washer. Use your thickness A, B, outer radius, inner radius. So you have each of the slices that we have. So the radius here, yeah, right, that's right. Thickness is dx. Yeah, sorry, I confused myself. Because clearly you can see like each of the slices have thickness dx. So the outer radius is going to be the height from, so the distance from this one to the radius of rotation. So whatever y value is here, you put it into whatever y value is here, and you're gonna minus 1. So let's see, value of x starting with is gonna start from x equal 0. So you set these two equal to one another. You have y equal 5 or y equal 1. Let's see what x is going along with it. So you have x equal 4, and then another x is at this point, which is x over here is going to be it's going to be at 0. So let's see where it crossed the thing. So it crosses 1 at y equal 3. So when y equal to 3, what is the value of x? So x is going to be 0. So it's going to transform from 0 to 4, the outer radius. Now you don't use two different curves that they give you. You have to look at the fact that, okay, this curve and this curve is the same curve, x of y minus 3 square, but it's just different side. In this one, it's going to be y equal, so the upper curve and the lower curve. What we have is square root of x is going to equal plus 3. So this is, so basically this one is y minus 3 equal plus or minus x. So the first curve is just the upper one, and the lower one is 3 minus square root of x is lower one. Because whatever you have here, you write everything in the form of x. So this is the upper curve, and this one is the lower curve of the same function. It's just the fact that now we have to write everything in the form of x, because this lower curve, the distance from this curve to y equal to 1 is going to be the inner radius, and the distance from the upper curve to y equal to 1 to be the outer radius. So the inner radius here is going to be 3 minus square root of x minus 1, or just 2 minus square root of x. The outer radius is going to be square root of x is 1 minus 1, which is square root of x plus 2. So here you eventually have the volume, which is from 0 to 4. And this is because everything you have to find boundary in the form of x is going to from 0 to 4. So this one is going to give you pi inner is the square root of x plus 2 square, outer is, and then 2 minus square root of x square dx. And so if you solve for it, you should get the same answer. So I would say in both scenarios, it's just both of the methods should work. It's just which one is easier and like easier both to set up and to do the calculations as well. So if you have any questions when you look at these slides at home, or just like don't understand what the heck I'm doing in one of the problem, please feel free to email me. I'll try my best to answer. Last week I will apologize for Chris because I have like an exam on Monday, so I kind of couldn't answer the questions, but this week it should be better. And so I'll put a note to myself. I'm going to check the email for you guys, so don't worry about that. If you don't have any more questions, try now all of the suggested practice problems, and I add one in, which is question 42 of section 5. Oh, actually, we just did it. Yeah, we don't need to worry about that. So if you don't have any questions anymore, I'm just going to end the sections here, and next week is going to be the final exam review. So I'll see you guys next week. Have a great weekend.